Here we go. So, believe it or not, actually, the Earth orbits the sun once every 365.25 days, which incorporates our leap year. Duh, right? 4 years equals that next day.
I just want to say they probably think we're stupid because they're probably emptying the water for a reason. They're probably going to refill it.
I can imagine how much water it would take for it to refill. And we've already said that the orbit is an elliptical, and it's not a circular path. It's an elliptical path. The other thing here that's important to us for us to know, it says here, contrary to the common beliefs, Earth changes its distance from the sun is not the reason for the seasons here. Instead, Earth, it says here, there you go, Earth's 23.5 degree axis or axial tilt is really the reason for the seasons. Okay? That's the reason that we have our seasons. Rather than Earth sitting here straight up and down, it actually has right here this 23.5 degrees of a tilt. And that's the reason. Are you closer to the Earth, or are you over here further from closer to the sun or further from the sun is the reason why we actually have our seasons. So, unlike what most people probably believe. It says here rotation. Earth, it says, spins once on its axis every 24 hours, which makes sense. That's the reason why we have our night and day, producing night and day. The rotation, it says here, is counterclockwise. Counterclockwise. If it was viewed from above the North Pole, which we know that is called the North Star is Polaris. It says the revolution. Earth moves around the sun at an average speed of about 30 kilometers per second as it's rotating around the sun. And we did talk about the tilt of Earth itself. Yes, it's 23.5 degrees, and that is the reason why we have our different seasons. And it says here that the tilt means that the Earth revolves around the sun, and with that revolving around the sun, it says here we have not only that, but our different hemispheres. So that's the reason why, I don't know if you ever noticed, or maybe you've seen it on the news or not, that we've got, if we're in summer, the southern hemisphere is going to be in their winter. You know, it's actually, we have different seasons because this part right here is going to be closer to the sun. This part right here is going to be further from the sun. Okay, so those different hemispheres are tilted towards or away at those two different times. Are you closer to the sun or are you further away from the sun? That tilt is going to cause those seasons. And again, while we're going through winter, they're going through summer on the southern hemisphere. It says changing the intensity or the duration, it says here, of the sunlight. And so again, that causes our seasons. Without this tilt though, without the tilt, Earth would have, it says over here, no seasons at all. It would be the same. Like whatever season that would be, if we were completely straight up, it would be the same because everybody would get the same amount of sun 24/7 year round, leading, it says here, to a more, where's my notes at? Leading to a more uniform climate. Every time I take my eyes off of the notes, I lose my spot. Ancient civilization, it says here, notice these patterns. Of the sun's rising and setting positions, and as it continued to change, right, it starts to, for us personally, when winter comes, it starts to get darker longer. When summer comes, we have more sun longer, right, leading to different monuments that they have created here, just showing regarding our seasons. Yes, yes, I went ahead and posted those pictures here. Absolutely. So let me go back. Here, it says here, using monuments like Stonehenge or Chichen Itza marks their solstice. So showing we have more sun, it's the summer, less sun, it's going to be our winter. But it, mhm.
That's supposed to be like a clock, like a sundial or whatever.
We actually, next unit, we will be making our sundials personally.
But that those rocks are supposed to be.
Those rocks were showing them their season depending on how the sun would hit it, and then they would see where that, like you said, the sundial, so that way they can see if they're having more sun or less sun. Same thing with it came to over here. This one, though, there's a really long video, but they were able to see when the sun actually rose up exactly on the top of the center would give it, and they would know like which day of the year it was. So I don't know, but that's how they were able to tell these seasons a long time ago. To me, that's kind of crazy. It says the Earth-Moon relationship. So we all already know that the Earth-Moon relationship has a lot to do with like our tides and other things. But I'm not sure if you know that the Earth is about 4 times larger, or you can say the moon is 4 times smaller, 1/4 of the diameter of Earth. So in physics, we use this information because we know the gravity here on Earth. And so in physics, we use this information of the size of the moon so that way we can figure out the gravity on the moon itself, since we know, the gravity here on Earth. It says that the moon orbits, it says here, Earth once every 27.3 days, which is a little bit off. Okay, but because the Earth is moving around the sun at the same time, the moon's phases, it says here, completes in 29.5 days. So I know I'm going to misspeak if I say it here. 27.3 days is what we call sidereal month, and 29.5 days is what we call synodic.
Oh, so
Synodic?
the moon
Thank you.
phases are
Months.
like
There you go.
sorta.
So
Are
it
there
depends.
months on the moon, sorta?
Well, it kind of throws off our moon phases because of that. Because this is not completely like our 30 days or 31 days with our however many days we have in our months. So here versus here. So here was a picture for us. Hopefully we can see that. Yes, we are rotating. This is Earth, and we are rotating around the sun itself, but yet our moon is rotating around us depending. So again, it causes that 27.3 days versus the 29.5 days. So let's keep going because I am not going to be able to pronounce that type of rotation.
So does the moon actually go in a circle around us, or it just looks like it does because we're spinning?
No, actually, good call. We have it here in our notes, but the moon itself rotates around Earth itself, and when it rotates around Earth, it actually rotates in the same direction. We only get to see half of the moon. That's a really good question. I'm going to go ahead and put a little line here. Here's Earth. We only see, and I'm going to write it over here. It's in our notes down here. We only see half of the moon.
Oh, so we've never seen the other side?
No, it's actually called the dark side of the moon. True story.
So like we've never seen the other side of the moon?
We have, but it's only because astronauts have been on that side. Yes. It's actually,
So that side is never lit up, or it does light up?
it does light up, but it's never seen by us. So if you see, for an example here, as the moon is rotating around us, this part of the moon is lit up. That was a good question that Levi had. This part of the moon is lit up, but it's not seen by us. As the moon continues to rotate, again, we only get to see, as it rotates, we only see this part of the moon. We never get to see the other part unless you're an astronaut that gets to go into outer space, and that is called the dark side of the moon. They actually have a name for it. One more time, it's called the dark side of the moon. And we personally don't get to see it. I mean, When you're looking at the moon, you're only looking at this part. This half is all you actually ever get to see. No, super good question, actually. Let me come back over here. So, synchronous rotation. Synchronous rotation is the moon rotates, it says here, on its axis once every orbit, meaning that on the same side or the near side is always faces Earth. So that was his question. There it is right there. Did I mess up? Oh, this is why it says here, this is why we never see the far side or the dark side of the moon without a spacecraft, unless you're an astronaut, so that way astronauts can see this side over here of the moon. We don't get to ever see it. Now, we do have a gravitational influence, and I know they probably talk about this in middle school or in younger grades, but gravitational influence, the moon's gravity is primarily caused, it says here, of our tides here on Earth, right? High tide and low tide, depending on where it's at when it comes around. So is it high tide or is it low tide? Stabilization, the moon's presence stabilizes the Earth's tilt itself, preventing, it says here, extreme wobbling. There's an actual video. I'll have to see if I can find that video. There's a video. It says, what would happen if we had no moon? What would happen if we had no moon? So wobbling would happening. There's a good chance we wouldn't actually not be where we're at compared to the sun, whether we would move further from the sun or closer to the sun because of this gravity pull that we have. What would happen to our tides if we had no moon? No tides. Can you imagine? No tides. Would that, I don't, well, the waves are actually due to convection currents from the wind is why we have waves. So we would probably still have waves, but no high tide, no low tides. What about all those sea creatures, like those little crabs or anything, you know what I mean? Without those tides. They would be. They would absolutely be. Crazy. So the Earth-Moon system is a unique system. I'll have to see if I can find that video itself. What would happen if we had no moon? We couldn't live without the sun itself. That is a guarantee. It says here, the sun's role. Now, the G-type sequence is the type of star that our sun was. So I went ahead and just typed in a little paragraph here just to give an example or a little bit more of what we call G-type sequence or G-type stars. So this paragraph is over G-type stars. And our sun is a G-type star. So it says here the sun is a G-type star itself, which is our sun, providing nearly, it says here, all of the energy for the Earth's climate and life here on Earth, right? We know that the sun is going to provide energy to our plants. Our plants are going to have photosynthesis. Our cows are going to eat the grass. We eat the cows. There is a chain of energy that continues to flow with that. The sun, it says also here, though, it has nuclear fusion that is occurring, and that's what this energy in its core, which converts hydrogen into helium. So it converts smaller atoms into larger atoms, releasing massive amounts of energy in the form of light and heat. But I thought it would be just a little interesting here just to kind of give a little bit of information. Our sun is halfway through its lifespan. Eventually it will die off. Again, though, it takes 8 minutes for the sunlight from the sun to hit Earth over here. But it's called a G-type star. And believe it or not, that's a whole unit over different types of stars. I went ahead and gave a few vocab words here versus us filling in the blanks this time or filling in the vocab. I thought, you know what, let's go ahead and just give it to us. Next part over here, historical perspective. Ancient cultures like farmers long time ago used to rely on lunar cycles so that way they knew when to harvest and when it's going to, and also for fishermen with high tides and low tides that would help them out. Scientific revolution, it says here, Copernicus. We talked about Copernicus himself a long time ago. And it says that Copernicus over here proposed of the, and we know this word, heliocentric model, shifting Earth from the center of the universe, and now it's the sun in the center of the universe. Or it's not even the universe, it's our personal solar system. We got a few questions over here. Questions should relate to the reading itself from that first couple of pages. First question here, Earth's distance from the sun is a primary cause of the seasons. Heck no. What's the primary cause of our seasons? It's due to the tilt. I'm going to go ahead and put here. Due to the tilt is the reason why we have seasons. Number 2, the moon complements or completes one rotation in the same amount of time as one orbit around Earth. Ooh, that is absolutely true. Next one, number 3. It says the sun's gravitational force makes up more than 99% of the total gravitational pull on the solar system. Believe it or not, that is absolutely true. That's because the sun itself is very large. Yes. Due to sun's mass, because it's so large. Number 4, the main reason for Earth's season is, well, we said that earlier, the tilt of the Earth. Let me go back. I don't want to misquote it, but our tilt is 23.5 degrees. And I'm going to put over here 23.5 degrees. Number 5, what is the length of a synodic month? Well, we have it in our notes that the length is 29.5 days. And then let me zoom in or scroll down. Number 6, which of the following is a result of the moon's gravitational influence on it? We all know from younger days of school the tides, high tides and low tides. Number 7, open-ended question. Explain why Earth experiences day and night. Well, Earth experiences day and night because Earth rotates on its axis, that 23.5 degrees, every 24 hours, one rotation. So because of that, different parts of the planet faces, that should be a C, faces the sun at different times, all right? This morning, I was texting a family member who's over in Europe right now. I told her, I don't know what time it is for you. Hope I'm not bothering you. And it was 7:30 this morning. She says it's 3 p.m. right now.
Yeah, because there's 7 hours.
So,
Yeah,
there you
friend
go.
is 6 hours
Oh.
away from the UK.
Oh, ahead?
Ahead, yeah.
Ahead. Okay, so there you go. I was like,
So
oh,
it depends, it could be 7, it could be 12.
I thought that was crazy. Causing day and night.
Yeah, so sometimes I'm like, oh, should I text him, should I not?
Right, right. I guess we can count up those 6 or 7 hours, 8 hours, but I was just like, hey, I'm just going to text her. If I wake her up, I wake her up.
Yeah, usually when you text them in the morning, it's better because it'll be
It's their
morning.
afternoon?
If you text them at night, they're probably going to be asleep.
Ugh.
Like if you text them around 7.
7 in the evening for us is like 2 a.m. or something. Okay, well, I'm glad I got her in the morning. Or her afternoon. So, yeah, she's there this week. Like, whoa, I told her, send me pictures. That's what I told her, send me pictures. Number 8, how does the moon help stabilize the Earth's climate? And it says here, over long periods. Well, the moon stabilizes the Earth's axis, or axial tilt, right? And helps prevents wobbling. So hopefully no one is allergic to Oreos, because we do have a little Oreo hands-on lab to do next week. Okay, I hate Oreos. We have bukus.
I like the cookie.
The Oreo cookies? Okay, yeah, we've got, I don't know why my kids buy those thingies. So there's this Oreo, okay, no joke, this was supposed to be like a younger students' activities. But I thought, you know what, we're going to do it with Oreos. We're young at heart. We are going to create the different moon phases with Oreos next week. That's what it is. So like I said, I hope we're all okay with Oreos. It says here the phases of the moon occurs because we actually see different portions of the moon's sunlight, Light, half as it orbits Earth. So the sun, or sunlit, I guess we should say sunlight or sunlit. Right? It doesn't have light itself. Actually, the moon, if there was no sun, you would never see it, because that's what lights the moon up, and then we see that reflection here on Earth. So, new moon. And no, this is nothing with vampires, right? My kids right now are all about it. The moon, it says here, the moon is between Earth and the sun. Its dark side faces us. There's nothing there. Next one, we have our waxing crescent. So a waxing crescent is a thin crescent like this of light glows or grows or glowing from the sun, and we're able to see that. Then we got the first quarter. The first quarter is actually half of the moon. Half of the moon right here. You can see that. Then we got our waxing gibbous. I probably pronouncing it more wrong. And this is more than half of it. So you can see it right here. More than half of it is shown. Then we got the full moon. And it says here, for the full moon, the Earth is between the sun and the moon, versus the moon is between the Earth and the sun. Then we keep going and we work our way backwards. So it's just reversing it. In this situation now, our warning, or it's no R in it. Pronounce it for me. There you go. I want to say an R. Decreasing the light after the